I prepared a small case study on barge transport systems and how to model them in Python using SimPy. And I developed a small simulation framework in Python for doing so, and a detailed problem description. You can find all of that in my blog in the form of a downloadable zip file that I made available in my shop. And there you will get much more detailed case study information, so more detailed problem description, and you will also find a problem-specific implementation and a general framework for modeling barge transport that I developed in Python. And basically, a barge transport system consists of boats that transport barges. They can transport several barges, and the barges are used for transporting cargo. So the barges can contain cargo, usually bulk material like grain or ores, coal, stuff like that. And then you will have a series of loading stations and a series of unloading stations that are all linked to underlying processes, production processes, supply processes, distribution processes. So they're all described in reality by certain availability schedules and also demand patterns. So the unloading stations have to receive the requested cargo in time. So the overall objective of a barge transport system, or simulating and optimizing a barge transport system, is of course to make sure that all of the unloading stations receive the requested cargo in time. And you can find a much more detailed description of this case study on my blog. I will show you real quick the content of this zip file that I made available in the shop of my blog. So there is a detailed program description here of this case study example that I developed, and then you will find a configuration file and a model file that specifically implement this case study. In addition to that, there's a framework file that consumes SimPy, which is a discrete event simulation module in Python, and I use SimPy and wrote another library around it that's specifically for barge transports, which I'm then consuming for this specific case study. So you can also access this framework when you download this zip file from my blog. And here I just quickly wanted to show you what this configuration file looks like. So here I navigated to the contents of this downloadable zip file, and you can see I opened the configuration file. There's certain settings that you can adjust here, and this is all specific for this specific case study description that I developed. So for example, you can adjust the number of barges that a boat can transport, the minimum amount and the maximum amount of barges that a boat can transport. You can also adjust speeds, unloading times, loading rates, and so on. So just a very basic configuration file, and then you will find the model implementation here, which consumes this framework that I also wrote in Python, and which is also contained by the downloadable zip file. So this is just one example, but you can use the framework to implement your own example. And if you need help for that, you can also contact me, and we can develop your problem together using this framework. And I can assist you in consuming this framework for your specific problem. But so basically, you see here, I consumed a framework to set up a simulation model. It's 50 lines of code, and this contains model building, so setting up the simulation model with the specific parameter values, executing the simulation model and collecting simulation data, and generating simulation plots. And in this case, the simulation will generate two plots. One is here, you can see the simulation time, and then you can see for each boat the number of deliveries of laden barges that it has made. So we have a loading station where empty barges are located in the beginning of the simulation, and then you have boats that are located on the river system, and then you will get here as one output of this model the number of laden barges that have been delivered by each boat throughout simulation time. So there's one metric that is plotted here and generated by this model file. And another metric is the position of each boat. So here you can see the position of each boat throughout the simulation. So in the beginning of the simulation, each boat is located at the loading station, and then they move to the unloading station where barges are unloaded in accordance with an unloading rate. And then you can see, in accordance with demand and the number of available barges for transport, the boats either move back to the loading station, transporting the empty barges, or if there are no barges to transport, then the boat simply stays at the unloading station and waits until there are empty barges that can be transported. In this case, boat number 3 stays for a full cycle, and when the other boats return again with laden barges and they're unloaded, the boat transports these empty barges back to the loading station. So a simple example with a problem description that is specific for barge transports, a framework that can be used for other scenarios, not just this scenario. You could also model a row of several unloading stations, several loading stations with schedules for each loading and unloading station, and also with distribution hubs where barges can be redistributed. And it's meant as an introduction to simulation modeling in Python and an introduction to SimPy. And I hope you will find this project interesting, and if you want to implement your own specific SimPy case, then you're welcome to contact me and we can take a look at it together.